To calculate allele frequency, let's discuss some variables. P represents the dominant allele, Q represents the recessive allele, and P plus Q equals 1. Because there are only two types of alleles, together they will equal 1. The standard equation for the Hardy-Weinberg principle is P squared plus 2PQ plus Q squared equals 1. Here's an example of a Punnett square. Each square represents a variable. The first box, with two capital R's, represents homozygous dominant alleles. The next two boxes, with a capital R and a lowercase r, represent the heterozygote alleles. And the last box, with two lowercase r's, represents the homozygous recessive alleles. Let's start with the blue-footed booby example. Webbed feet represent the recessive trait, and non-webbed feet represent the dominant trait. If the frequency of the Q allele is 20%, find the frequency of homozygous recessive, homozygous dominant, and heterozygous individuals. So, if the Q allele frequency is 20%, that would mean Q equals 0.2. When we replace the Q in the equation P plus Q equals 1 as 0.2 and solve for P, we find that P, which is the dominant allele, equals 0.8. To calculate the homozygous dominant individuals, you must square P. 0.8 squared equals 0.64. This means 64% of the population is homozygous dominant for this allele, and in this case, they have non-webbed feet. The same concept is used to calculate homozygous recessive alleles. Q squared, or 0.2 squared, is 0.04, which represents the homozygous recessive allele. This means 4% of the population has webbed feet. To calculate the heterozygous allele, the whole equation is used. You can plug in the values for Q squared and P squared that you found and solve for 2PQ. In this case, we found 2PQ to be 0.32, which is the heterozygous allele. This means 32% of the population look homozygous dominant with non-webbed feet, but are genotypic carriers of the webbed feet trait. Now, let's try an example with snapdragons, which show codominance. In other words, the heterozygote yields a different phenotype, in this case, which is pink. Red is homozygous dominant, and represented by P squared, and homozygous recessive is white, and represented by Q squared. Because there are three phenotypes in this codominant example, P does not represent the homozygous and heterozygous alleles combined, as it usually does. If 81% of the population is red, and therefore dominant, you can take the square root of 0.81 to find the frequency of the P allele, which becomes 0.9. Using the equation P plus Q equals 1, the frequency of the Q allele is 0.1. If 0.1 is squared, then the numbers yield the homozygous recessive phenotype as 0.01, meaning 1% of the population is white. Then, to find the frequency of the heterozygotes, the equation P squared plus 2PQ plus Q squared is used. 0.9 squared plus 0.1 squared plus 2PQ can be simplified to yield 0.18 as the heterozygote frequency, meaning 18% of the population is pink. Thanks for watching. Aren't you glad this wasn't on the AP test?
Created using Powtoon.